Okay, now we're going to look at some questions with regards to scatter plots, with regards to their trends, and we're going to look at independent and dependent variables. So we're going to focus on interpreting scatter plots and determining whether a trend exists. So first question here. Which of the following collections of data could be represented on a scatter plot? Could the distance commuters travel to work, the time commuters take to travel to work, the distance and the time commuters take to travel to work, or the age of the commuters who travel to work? Well, with a scatter plot, you're going to need an independent and a dependent variable. If you look at example A, the distance commuters travel to work. Well, what are we comparing that to? We don't really have a whole lot of information here. We only have one variable, and that's the distance. How about in B? The time commuters travel to work, or time commuters take to travel to work. Again, we're measuring time, but compared to what? We don't have anything else to compare to. We are only looking at one variable, and that's time. In C, we have the distance and the time commuters take to travel to work. Well, this would be an example where we have two variables. The distance that someone takes to travel to work would have an effect on the time it takes them to travel to work. So we have two variables, the distance and time. We have an independent distance and time, which is dependent. So in this case, our answer is going to be C. And just to check on that, for D, it says the age of commuters who travel to work. Well, the age, well, again, that's one variable. It's only their age, and it's completely random. So that wouldn't be a good example to try to plot on a scatter plot. So C is the answer. We have two variables, an independent distance, and a dependent time. Okay, the graph compares a lobster's mass in pounds to its estimated age in years. Describe the trend shown by the data points. Well, there's a positive trend, definitely, because as the age goes up, so does the mass, or in pounds. So it's a positive trend. And it also appears to be pretty much linear. It appears to be pretty much a straight line. So there's a positive linear trend between the mass, or between the age, and the age is your independent variable, and the mass of the lobster, which is your dependent variable. So what it's saying is that as a lobster gets older, it's also going to grow in size. Now we're asked to extrapolate the weight of a 9-year-old lobster. Well, to do that, I'm going to have to draw a straight line through my data. So my straight line, I'm going to use a straight ruled line here. It's going to be about there. That's a line of best fit to the best of my abilities. Okay, so I'm going to extrapolate. Now, extrapolate means to go and extend your data. So my line is extended beyond what I have available right now. Extrapolate the weight of a 9-year-old lobster. Well, you can see that every 2 grid lines is equal to 1 year. So 9 would be about right here. So this is 9 years of age right here. So what I'm going to have to do is draw a straight line up to 9 years, and where it meets my graph, I'm going to extend over to the end here. So by extrapolating, I find that the weight of a 9-year-old lobster is about 40 pounds. So it's about 40 pounds. This is an L. I make it look more like an L. So why don't I just try writing that out again? 40 pounds. That's better. Much easier to see. It's not 401 BS. So 40 pounds is the weight of a 9-year-old lobster by extrapolation. Interpolate the age of a 25-pound lobster. Okay, so the first thing again, I'm going to have to draw my line of best fit, which is about that. Okay, so I'm going to interpolate, which means that I'm going to find a value within the set of data that I'm provided. So to do that, I'm going to draw a line from 25 pounds to my graph, and then I'm going to extend that line downwards to here. So the age of a 25-pound lobster appears to be, based on interpolation, about 5.5, 5.6 years. Oops, I got to change to a pin. About 5.5 to 5.6 years old. So that's interpolation. Within the data that I'm given, within the data I'm given, I'm able to find the a certain value using my line of best fit. The record mass for lobster is 44 pounds. Is it possible to estimate its age from the scatter plot? If yes, estimate its age. If no, why is it not possible? So I would have to draw my line of best fit again, which is about this. Okay, so 44 pounds, I'm doing an extrapolation. 44 pounds is approximately up here. So I can extend that over to where it meets the line and extend that down. So what this is telling me is that based on the graph that I'm currently given, it wouldn't be possible to estimate its age. Oh, once again, gotta get a pen. No, because in this case, we're well off our graph. We're well off our scale. We'd have to do a lot to get a value here. We'd have to, if we had just drawn our scatter plot bigger to begin with, we would have no problem. No, because the scatter plot as drawn is too small to extrapolate the age of a 44-pound lobster. Now, if we can do a very, very rough try at this, this would be about 10 right here. So it might be about 10.5, but ideally, we would draw our scatter plot to be large enough to be able to do a proper extrapolation. It's very close, but I think we're outside the range, acceptable range for being able to do this, and it's purely due to the fact that we drew our scatter plot too small to begin with. So it's always a good idea to make sure that when you're drawing something like this, that you make sure that it fits the data as you would expect it to be. Okay, so to summarize again, when we're dealing with this type of question, a scatter plot is a graph with points that show a relationship between an independent variable and a dependent variable. The independent variable is the manipulated variable and is always graphed on the horizontal axis, or the x-axis. The dependent variable changes as a result of the independent variable and is graphed on the vertical axis, which is the y-axis. And a trend shows the general direction that values move in. So we may have positive trends, whereas one variable grows, the other grows as well. Or we might have a negative trend, whereas one variable grows, the other gets smaller. Or we may not see a trend at all. We don't see any discernible relationship between one variable and the other. And in a case like that, our data appears to be completely random on our scatter plot.